Hi, I'm Gidon from technologyman.com. The FLSUN Super Racer is capable of printing up to 3 times faster than your conventional 3D printer, and it has auto bed leveling, a 3.5-inch touchscreen and a large print volume. I'll find out how easy it is to set up and use, and I'll put their claims to the test to see just how fast it can print a variety of materials, and how these faster speeds affect print quality. If you're new to 3D printing, I'd highly recommend watching at least some of my earlier video that introduces the technology with the budget Creality Ender 3. I'll provide a link on screen and down in the description, and there'll be full timestamps if you just want to skip to the chapter of this review you're interested in. So let's take a closer look. The printer comes in a large long box and requires some assembly. There are quite a few parts and assembly does look a little intimidating. But there are clear instructions in the supplied user manual and there's a useful accompanying video too. I'd recommend watching the video first for an overview and then following the instructions in the manual to make sure you don't miss any steps. It'll take 30 to 60 minutes to assemble depending on your previous experience. And it is far easier than it initially seems. All the tools you need to assemble the printer are included, and FLSUN include a generous selection of spares too, including almost a complete spare hotend together with a spare heater and thermistor. There's also a microSD card reader with a 4GB microSD card loaded with an electronic version of the user guide, a test print and links to set up and troubleshooting videos. There's even a piece of sandpaper to clean up your prints. You put it together upside down, attaching the 3 800mm axes to the top with the supplied M4 bolts. You'll need to plug in the corresponding stepper motor cable for each axis, which is clearly labelled, before you attach it. Then you bolt the base to the top of the partial assembly in the same way, making sure the FLSUN logo on the base aligns with the logo on the front of the glass build plate. The base has metal tabs which support it while you screw in the bolts, but it's a little precarious. I attached a single bolt to 2 sides before installing the remaining bolts. Then the touchscreen bracket slides into the groove of the right axis. You'll need to unscrew the bolt from the T-nut so it's flush before sliding it in. Then you can tighten to lock it in place around 1/3 of the way from the top before turning the printer the correct way up to continue assembly. The hot end of the printer is already installed in the so-called effector module, which attaches to the linear slides on the 3 vertical axes with lightweight spring-loaded carbon parallel arms. No tools are required to install the parallel arms, just pull them apart slightly and attach all 3 of them to the linear rails first. Then you can attach them to the effector module in the same way, with the FLSUN logo facing forward. The springs are quite tight, so make sure you don't nip your finger. Attach the colour-coded cables from the main board to this module. The 2 black connectors can be connected either way around. Then attach the main cable to the top of the unit with its keyed 5-pin connector and tuck the loose cable neatly into the groove of the axis. Next, attach the extruder assembly, making sure the PTFE tube from the top of the printer lines up with the filament sensor. This hangs from the top of the printer and is secured with 2 bolts. Plug in the filament sensor and extruder motor cable and push in the PTFE tube from the hot end into the bottom of the extruder and secure it with a white clip. Finally, lightly tie the PTFE tube to the main cable, assemble the basic filament holder and attach it to the top of the printer. Peel off the protective film from the glass bed and wipe it clean of any possible grease with IPA, which I'd recommend doing before every print. By default, the voltage is set to 230 volts, which is correct here in the UK. But make sure you change the red switch to 115 volts in the US or anywhere else on 115 volts before you turn the printer on. I found the supplied mains cable was a loose fit, so used the spare cable I had. It is a standard kettle or IEC power lead, but I'd have expected better quality. The printer has automatic bed leveling, but unusually you'll need to attach the leveling sensor every time you level the bed, and must remember to remove it afterwards. Fortunately, since the bed is stationary, you only really need to do this occasionally, for example after a nozzle change or if you update the firmware. Connect the leveling switch to the cable labelled level and then attach the sensor magnetically, just in front of the nozzle. Turn on the printer and tap Tools, Heat, PLA to heat up the bed and nozzle. When the printer is heated up, tap Tools, Auto Level, then Auto Leveling and confirm that the leveling switch is attached. The leveling process is quite slow, taking around 3 minutes. You can then remove the leveling switch and set the Z offset, which adjusts exactly how far the nozzle is from the bed. Tap Move Z0 and this time confirm the leveling switch is removed. Use a piece of plain paper underneath the nozzle to set the nozzle height. Tap Adjust Z0 and move the nozzle until it just touches the paper. You should still be able to move the paper with just a little resistance. It's important you do this when the nozzle and bed are hot to take account of expansion, otherwise the nozzle may dig into the bed when you go to print. With filament loaded, it also ensures any melted filament is cleaned off the nozzle when you drag the paper around. Then tap Save, which records this Z offset and moves the print head back to its home position. You're now ready to load filament. There is a small spool of test filament, but I used some Prusa silver PLA I had to hand. Load the roll onto the filament holder, cut the end of the filament at a 45-degree angle and feed it through the hole in the top of the printer, down through the filament runout sensor, and then guide it in through the PTFE tube of the extruder. Make sure the temperature of the nozzle is set appropriately for the filament you have loaded, and tap Tools, Change, and then tap In while pushing the filament into the extruder gears. You also have the option to set the nozzle temperature here. You might have to slightly twist the filament to make sure it's pulled through the extruder into the PTFE tube below. The filament will be pulled through to the nozzle. Click Stop when some filament has been extruded. In general use, I'd suggest tapping Stop when it reaches the hot end and using the Tools Extrude option to actually push filament through the nozzle. The Change function puts unnecessary stress on the extruder. Even though it's what the manual suggests, it's far too fast for extruding filament, and you'll hear clicking from the extruder. The FLSUN Super Racer is a delta printer, which means it's built for speed, with a very light print head that hangs off arms attached to linear guide rails on 3 vertical axes. These 3 arms move independently, and with some clever trigonometry calculations allow the nozzle to be precisely and quickly moved anywhere in 3D space. The Super Racer claims print speeds of up to 200mm per second, around 3 times faster than a standard Cartesian 3D printer like an Ender 3 or a Prusa Mark 3S Plus. I'll discuss print speeds and how they compare shortly, but typically this printer is about twice as fast as the fastest conventional 3D printers I have, with the same nozzle size and layer height. However, they are much taller than these conventional printers and tend to be a little more expensive too. This printer with a filament spool on top of it is over 1 metre tall, almost twice the height of my Prusa Mark 3S Plus. You can see its exact dimensions and its weight on screen. Although the head moves around differently, in all other ways it's just like any other FDM printer. It uses a longer volcano-style 0.4mm nozzle with part cooling fans either side. This is fed via a Bowden setup with 565mm of PTFE tubing from a cheap clone of the dual-drive Bondtech BMG extruder. It has a build volume with a 260mm diameter and 330mm height, although it loses a little of that maximum height as it moves out from the centre of the coated circular glass bed. I would have much preferred a removable flexible PEI sheet like on my Prusa printers and the Anycubic Viper I reviewed recently. The printer has a rather nice 3.5-inch touchscreen, which is very responsive and can be detached from the rail for easy use. It doesn't show print thumbnails, and you can't control any of the printer's advanced settings like flow rate, but for most people it'd be fine. And you can connect the printer with a USB cable to Pronterface or control it wirelessly via Octoprint if you want more control, both via the USB-B port on the side of the printer. Beside the USB-B port, there is a USB-A port for connecting a USB stick, and next to that a microSD card slot, which is enabled by default. To use this USB port, you bizarrely have to flash the firmware, which isn't exactly user-friendly. Before I started the first print, I upgraded the printer firmware, which you can download from FLSUN's website. The latest firmware has smaller Z offset adjustments, 0.0125mm, compared to the fairly coarse 0.05mm adjustments of the firmware supplied with my printer, which makes it easier to set a perfect first layer, although these smaller steps aren't available when adjusting live Z height during a print, only the larger 0.05mm steps. The user manual describes the process to update the mainboard's firmware, but you'll also need to update the touchscreen firmware, which is not well documented. Back up the contents of the microSD card and format the card with a 32KB allocation unit size. Then copy the .bin file from the Nano V3 TF card to the root of the microSD card and turn on the printer with the card inserted. Then you need to update the touchscreen. Again, format the card, but this time with a 4096 byte allocation unit size. Use a command prompt and enter the command on screen. Copy the dwin_set folder to the root of the microSD card, turn the printer off and remove the back cover from the screen, which reveals a microSD card slot. Insert the card into this slot and turn the printer on. When end appears at the top of the screen, turn the printer off, remove the card and reattach the cover. Turn the printer on and confirm you now have the latest firmware under Info, in my case version 1.3. Reformat the card with 32KB allocation unit size and copy the file you want to print across. I started with the nut and bolt test.g code that came with the printer. Be careful with file names since the display only shows 22 characters. I got an almost perfect first layer and the print completed with the nut and bolt fitting together nicely, but I did notice the high-speed infill was a bit of a mess. I then tried a more demanding model sliced myself in FLSUN's preferred slicing software, Cura. I recommend downloading the latest version of Cura, not using the version on the SD card. I was pleased to see Cura already has this printer in its database, so all you need to do is find the FLSUN Super Racer in the printer list on the program's startup. 2 profiles are included, a fast normal 150mm per second profile at a 0.2mm layer height, and a slower fine profile at 80mm per second and a 0.12mm layer height. I sliced a 3D Benchy model with normal settings, again with Prusa Silver PLA. It started okay, but as before it looked like the printer couldn't keep up with the infill speed settings and this print failed. I was pretty sure there was an issue with a cheap extruder. Even when loading filament, I could hear it clicking and missing steps. And if you tighten the tension adjuster knob, the gear just chews through your filament. Raising the temperature of the nozzle, which should put less demands on the extruder, didn't help. I pinched the extruder off my Anycubic Viper, which is pretty much identical, but had the same issue. I then turned my attention to the hot end. It appeared I already had a partially clogged hot end. I tried a cold pull to clean out the hot end, that didn't help. So with the temperature at 240 degrees centigrade, I removed the nozzle and cleaned it with a small butane torch and the supplied acupuncture needle. Then I removed the PTFE tubing from the hot end and cleaned it out with one of the supplied Allen keys. I reattached the nozzle, making sure it was tight against the heat break whilst holding the heater block securely. Unfortunately, this is not an all-metal hot end, and the PTFE tube goes all the way through the heat break and contacts the nozzle inside the heater block. You need to make sure there is no gap. Put a piece of folded cardboard underneath the nozzle to protect the bed, and manually push the nozzle down onto the cardboard. Then push the PTFE tube in as far as it will go and insert the white locking clip. Check there's no movement as you pull the PTFE tubing up and down. If there is any movement, remove the clip and again try and push the PTFE tubing as far as it will go. At this stage I also connected to the printer wirelessly via Octoprint to calibrate the extruder. It was under extruding slightly. I had to change the E-steps from 410 to 416. Since I thoroughly cleaned the hot end, I've had far better results. This shouldn't happen after one test print with PLA. I tried the 3D Benchy print again and this time it completed successfully. I used red FLSUN PLA+. There is a little bit of very fine stringing, but that's more likely due to the filament not being completely dry. And the cooling is not quite sufficient at these high speeds around the hull of the boat with its steep overhangs. You can also see some ghosting or ringing if you look closely. But the print was completed in just 41 minutes. That's less than half the time the print takes on my considerably more expensive Prusa machine, with Prusa's 0.2mm 60mm per second speed setting. I also tried this print with a fine setting, but changed the layer height to 0.2mm. This print is better quality. The hull overhangs printed better and there's no noticeable ghosting, but it's fairly difficult to tell them apart unless you look closely. And this printed in 58 minutes, still considerably faster than the Prusa. Just for fun, I tweaked the 150mm per second profile to see how fast I could print the 3D Benchy. I upped the speed to 220mm per second and enabled jerk control. This print completed successfully in 34 minutes, which is very impressive. It looks similar to the 150mm per second print with just a little more ghosting. To test the dimensional accuracy, I printed a calibration cube, and even with 150mm per second normal setting, the accuracy was about as good as you can expect from FDM printing, which I wasn't expecting. As a more demanding test, I tried a tough, longer print. This A-Team van from Fab 365 took just 5 hours 19 minutes to print, again at 150mm per second and 0.2mm layer height. The same print would take double that time on any other FDM printer I've tested. This print uses up a good portion of the print bed, so there's a good test of auto levelling. And since it's a foldable model, tolerances need to be just right. I left this overnight and was honestly not expecting it to print successfully. If you let the glass bed cool right down, prints do come off quite easily, and the first layer looks almost perfect. It also snapped together about as well as any other print I've tried like this that normally takes a lot longer. The live hinges all printed successfully and the wheels spin as they should. I tried a couple of larger Vase prints in Anycubic white PLA, which also printed very nicely and quickly. This 14cm tool vase printed in 1 hour 7 minutes. And this more complex vase my daughter wanted for her IKEA plant printed in 2 hours 38 minutes. Both were printed in Vase mode, which prints in one continuous spiral at 150mm per second and 0.2mm layer height. If you don't have the patience to let the bed cool down, prints are harder to remove and you'll need the supplied spatula. If they're really tough to get off, check you haven't got your Z offset too low. The printer has a filament runout sensor, which I tested next. When the sensor detects no filament, you'll get a prompt to change the filament. The printer head lifts off the print and you'll be presented with a change filament menu to unload the existing filament and load the new filament. It's a good idea to have some tweezers handy to remove any excess filament. When you're done, you can tap back and the print continues from where it left off. The bed stays at temperature and it worked pretty well for me. I also unplugged the printer mid-print to simulate a power cut and test the print resume feature. When the printer has power again, you'll get a prompt to continue the print. The nozzle lifts off the print and the bed and nozzle heats up to temperature and then continues from where it left off. There will be a small blob of filament where the print was interrupted, but if you're lucky it won't noticeably mess up the print. This little ratchet clip still looked okay and worked fine after this interruption. As I mentioned earlier, the printer should be capable of printing PETG, even though FLSUN didn't recommend it when I contacted them for a profile. I think the reason for this is print speed. This is marketed as a fast printer, but it's just not up to printing PETG, which requires a higher temperature than PLA at these higher speeds. Typically, PETG needs to be printed at around 240 to 250 degrees centigrade. But if you want to print at higher speeds with a somewhat weak extruder, you need to up this by at least 10 centigrade, which is beyond the capabilities of the hot end. You'd really need to upgrade to an all-metal hot end for these higher temperatures, since at 250 degrees centigrade, the PTFE tubing can start to degrade. I spent a considerable amount of time trying to perfect a PETG profile in Cura. I did eventually arrive at something that gave decent results, albeit at much lower speeds. I brought the speed down to 50mm per second, turned down part cooling, and printed at 245 degrees centigrade with Pronterface Galaxy Black PETG. After further experimentation with retraction settings, I had to increase retraction to 7.5mm to reduce stringing, but left retraction speed at 40mm per second. With these settings, I got some more than acceptable results. 3D Benchy looks good with no significant issues, but I did find whatever adjustments I made, there was a little warping. The bed was thoroughly clean with IPA, Z offset was adjusted correctly, and I tried turning off cooling for more than just the first few layers, which helped the most. But as you can see again, with this small box, the print still lifted slightly on the corners. I had to resort to using a brim in the end to keep it stuck down. I think this glass bed is just more suited to PLA. I also tried printing flexible filament, which isn't even listed as a supported material. Again, no profile is included, but I just slowed down the PETG profile further to 30mm per second and turned off cooling completely. I used Filatech FLSUN 40 to print this push-in flexible hook. It came out very well and wasn't too difficult to release from the bed, which I thought might be an issue. I have the tension adjuster knob on the extruder very lightly tightened, even for PLA, and left it the same for this flexible filament. I didn't try more flexible filament like Ninja Flex, but I imagine that may be too much for this cheap extruder together with the Bowden setup. The nozzle and bed heat up fairly quickly and typically draw up to 300 watts from the built-in 360 watt power supply. I measured around 2 minutes 20 seconds to get the nozzle to 215 degrees centigrade and the bed to 60 degrees centigrade, about 25 seconds slower than my Prusa Mark III S Plus. The heated glass bed did have some variation in temperature, around 7 or 8 degrees with the bed set to 80 degrees centigrade, as you can see from the FLIR thermal imaging camera. But I didn't find this affected any of my prints. The printer has a 32-bit mainboard with silent stepper drivers, and the X, Y and Z movements are very quiet, but the power supply fan, which is always on, is quite loud, as is the hot end cooling fan. But it's actually the extruder that's most noticeable when printing, especially with the large retractions. I also found with some prints there was some rattling with faster print moves. Despite a slightly shaky start with the clogged nozzle, I've been impressed with the FLSUN Super Racer. If you want to print PLA fast, it's the best option I've tested so far. Yes, you can swap to larger nozzles on non-Delta 3D printers to increase speed, but you lose resolution, and for a lot of prints the Super Racer will still be faster, and with a standard 0.4mm nozzle and 0.2mm layer height. Print quality even at 150mm per second was pretty good. There was some ghosting and the part cooling fans were a little underpowered, but I found the quality good enough for most of what I like to print. Dropping the speed to 80mm per second, the printer was still quite quick and the quality was definitely improved. The auto bed leveling also works really well, and since you only have to do it very occasionally and not before every print, prints start quickly too. I did successfully print PETG and flexible filaments with this printer. Without any upgrades, you'll have to drop the speed right down. And I'd really like to see FLSUN include profiles for these plastics. Without an all-metal hot end, you won't be able to print any high temperature materials like nylon or polycarbonate, and very flexible filaments will be difficult with this Bowden setup. With its stationary bed, the desk space you need to use this printer is actually less than most of my other printers, but you will need a lot of space above it. In use, the touchscreen is nice to use, but the microSD slot is a little awkward to get to, and switching to the USB port shouldn't require flashing the firmware. And updating the firmware, which includes removing the back of the LCD screen, is overly difficult and not well documented. I did contact FLSUN when I had the issue with the early failed prints. I always like to see what sort of support is offered with any tech I review. Unfortunately, I just got a single line reply to watch a third-party YouTube video on someone taking apart the extruder. So you're really on your own with this printer. Your best bet is a fairly active Facebook group if you have any issues. But I am pleased to see that spare parts seem to be readily available from local suppliers like 3D Jake in Europe. This printer makes most sense if you print predominantly with PLA. If you tend to use PETG most of the time, you're not going to benefit from its higher speeds. And there are cheaper printers that will do a similar or better job, like the Prusa Mini or the Anycubic Viper, for example. Unless you plan to upgrade the printer, that is. I normally like to keep printers stock, but I do plan a few upgrades with the Super Racer, some that I've already ordered. So let me know if you want to see a follow-up video. But I'd love to hear your thoughts. If you have this printer, what do you think of it? What upgrades would you recommend? And if there's another printer you want me to look at, let me know. As always, if you have any questions, please ask. I read every comment and I'll do my best to respond. I do hope you found this video useful. Please like the video if you did. I'm releasing videos every week on the latest technology and how to get the most out of it, so please make sure you subscribe. And don't forget to tap the bell icon if you want to get notified as soon as a new video gets uploaded. Thanks for watching.